If you don't know me, I'm Shawn Hawkins. I'm a specialist with UT Extension. I work mainly with animal waste management issues. The study today is kind of a study where I stepped in. We had someone who was retiring, and this work needed to be done. And so it's not really my area of expertise, but I've done the best I could, and we've collected a lot of data, and I think it's a good service for you all and very, very beneficial. I certainly didn't do it by myself. This study has been exhaustive, and I've got a research associate, Hannah McClellan, who deserves a lot of the credit. She collected a lot of the samples and organized the data for me, and Wesley Wright, our research associate. And last, Tennessee Department of Agriculture, if anyone is here with Department of Ag. Okay. I want to thank them for the support to be able to do this project. It's expensive, to conduct this kind of research where it's replicated at the level that we did. So I want to acknowledge them and thank them for the support to be able to do it. So mainly what we're looking at in this study is we're trying to determine whether or not we need to make a change in our fertilizer recommendations for corn silage and specifically for nitrogen. And what brought this about is that we have a disparity in our nitrogen recommendations for grain and silage. And you all have heard me talk about this last year. We have 5 tiers of nitrogen recommendations for corn grain, and they range from 120 to 240 pounds of nitrogen an acre. And if you look at the amount of nitrogen we're recommending per bushel, it's as it should be. It should be slightly more than 1, and that's what it is. Conventionally, that's what we would expect. More? So I'll speak a little louder. In silage, that's not the case. We have 3 tiers. If you look at the nitrogen equivalent that we're applying per bushel, on our upper tier, we're actually less than 1 pound per bushel an acre. So that was one of the issues that was brought to our attention. And why we're doing the study is to figure out whether or not we in fact want to change these. Obviously, these changes have implications for manure management. That's why I'm involved. So we have to collect the data and justify the changes that we're making. Because ultimately, when it comes to manure applications, we have to be able to justify and identify a maximum rate. And a part of that, of course, is we have a goal that we're shooting for nitrogen, and we don't want to exceed what we can agronomically justify. Corn silage yields have increased over time, as the case for every other crop. To be honest with you, it's not possible for UT Extension for every crop to maintain a continuous agronomic trial. It's not possible. We just physically can't do it. That being said, we heard the criticism that it has been quite some time since we've done a nitrogen trial for corn silage. The best I can figure, 1995 maybe. I can't actually even find the publications from it. And I can't find the original data from where our tiers come from. So that's just being completely honest. During that time, we have seen obviously an increase in corn silage yields. So that gives credence to this idea that, it's definitely time for us to revisit this and see whether or not we need to be increasing our corn silage nitrogen recommendations. One of the other considerations, of course, is that, our varieties that we use now for both grain and silage are very different than they were 25 years ago. So, when I was examining this issue, I had some question about, whether or not perhaps some of the new varieties have differences in composition and quality that are important, and so we wanted to incorporate that into the study. Over the last 5 years or so, corn silage yields, the average nationally in Tennessee has been pretty flat. It's been about 20 tons an acre. It's been my experience on the experiment stations that we generally can get higher yields than that, and I know many of you can. So. And we see that in some of our variety tests. This is Fred Allen's data and Virginia Sykes' data. If you look at the data, there's clear evidence that, in some years, obviously, we're able to exceed that upper yield threshold that you've seen in our nitrogen recommendations, that 25 ton an acre threshold. We've exceeded it 4 times in 17 years. All of this to say that, it is time for us to do the study. When it comes to this issue of corn silage composition, in my opinion, there's nothing more important in this study, frankly, maybe even more important than the nitrogen recommendations, than documenting what our phosphorus removal rates are, because that's really important for you all. You all have to have an estimate of phosphorus removal rates for your crop, and you turn around and, of course, use that estimate to justify your manure application rates. Listen, it's important that we be efficient, right? Everyone in here knows that the dairyman must be efficient today. So if our recommendations, or if what we're estimating for corn silage phosphorus removal rates are inaccurate, that needs to be remedied. Right now, what we're using is an estimated removal rate of 3.6 pounds of P2O5 per ton of silage removed. That's at 65% moisture. And that number comes from the software that you all are familiar with. When we write nutrient management plans, vast majority of the NMPs and CNMPs are written using MMP. And this is what the software uses to set your manure application rates. So we want to make sure that this number is accurate. There are other estimates, and they're not the same. The reality is, and you know, I've learned this since I've come to agriculture in 2007, there's a lot of variability in everything we do when we farm. So the fact that we don't have a single estimate of what the phosphorus removal rates doesn't surprise me. So we wanted to, as a second part of the study, verify our phosphorus and potassium removal rates. One of the other things I wanted to do in the study is investigate methods to assess the corn silage and see whether or not, in fact, we do have nitrogen deficiencies, because particularly when you're managing manure, your number one concern is going to be, am I getting enough nitrogen on with manure? I'm glad that's not me. Last meeting I was at, I had a new cell phone. I didn't realize that when you turn the ringer off, it didn't turn all the text. It took me about 5 minutes to figure out how to turn it off. So, we wanted to investigate methods and see whether or not we could find a facile, kind of an easy way for a producer to go out and say, okay, you know, do I have a nitrogen deficiency here? I put manure on at planting. It looks like it's deficient. Is there a method for us that's easy, inexpensive for us to access it? We did collect data using GreenSeeker. It's not a complicated instrument. It basically has a light source and it measures green light reflectance back to it. It creates a number, and then you index that number to a part of your field where you've applied a high rate of nitrogen. And then we have another meter called SPAD, which basically clamps onto the meter. The light source there transmits through the leaf. The measurement device is on the other side of the leaf, and it just measures how much of the green light actually gets through. And it's an index basically for the chlorophyll content of the leaf. These do not work well. I'm not even going to present the data today. It's, you know, it doesn't work. So I'm not going to waste your time presenting it. Don't use it. The other thing we did is we tried to make some assessment of late season nitrogen deficiency using corn ear leaf samples. That worked marginally well. I'm going to emphasize the N and P and K removal and the work we did at Little River today. But you know, you could just be aware that that's a pretty good test that you can use. It's simple. You just cut the leaf off, put it in a bag, send it, and they'll give you an indexed value of what the nitrogen is, and you can assess whether or not you had a nitrogen deficiency issue. Is there anything that you can do about that at that point? You know, the weakness of that test is, of course, it's just diagnostic. Once you get the information, you can look back and say, what if? But you can't use it to correct the problem. So, okay, so we had two different studies that we actually did. We did small plot work where we didn't use any manure. The reason we didn't use any manure is because we don't want any ambiguity, any unknown factors in how much nitrogen we're putting on. Because anytime you put manure on, that nitrogen is going to become available variably depending on weather, temperature, precipitation. So in the first part of the study, we had small plot work, and this is the treatments that we had. We did use a negative control where we did not apply nitrogen fertilizer. We did put P and K fertilizer on. I'm really glad that we did the negative control because a lot of times it's hard to tell the difference between our other treatments. Those rates vary. Basically, they mimic the grain recommendations, 120, 150, 180, 210, 240 pounds of nitrogen an acre. And then we threw in a 300 just to see whether or not we had some yield suppression and silage quality issues at that point. All of that was put on with Agritane. We did use the same variety of corn silage every year. Many of you all know I called you and asked you for a recommendation on which variety we tested, and so we used Pioneer 2088. But we would expect that the study results would be similar across varieties. We did split the application. So at planting, we put down 80 pounds of nitrogen an acre as urea with Agritane, and then at V6, as best we could target it, depending on weather, we put an additional allocate of nitrogen out to come to our total, 120 through 300 pounds of nitrogen an acre. Okay, so the first thing I want to talk about is yield. Gross yield is obviously very important. That gives you the bulk of your ration, so it's critical, that we're adding enough nitrogen to make sure that we're maximizing our yields. And I showed you part of this data last year. We didn't have a lot of differences, frankly, between our treatments. In 2017, all of our treatments, other than the zero nitrogen control, basically yielded the same thing. It was a great year. We had really good results. So when you get perfect rainfall and you have a little bit of nitrogen in the soil that's going to be available from perhaps organic matter, this is what you get. There'll be some years where you could put out 120 pounds of nitrogen and you're going to get the same yield that you're going to get if you put out 240. And that was one of the years. We did, in large part, have a repeat of that in 2018, although we do see some linearity in the data here. These numbers down here are the mean and the standard deviation, and the letters establish if there's significant differences between them. If any of these values share a letter with the other one, then it's not different. And you can see all of the values from 120 to 300 share an A. So there's so much variability in the results that we're getting that we can't really say that there's true differences between, say, 150 and 240 pounds of nitrogen an acre. That being said, anytime we have data that lines up like this, that's some indication that our treatment, in this case our nitrogen application rate, is having an effect on yield, because we see a steady increase in yield, 21 to 22 to 23 to 25 to 26 tons an acre. This is hot off the press. We didn't have as good a year this year. It turned off very dry. We had some rust come in some of the plots, so our yields were down this year. But again, you see that trend of small increases in yield that span our nitrogen treatments, from 120 pounds an acre at a yield of 19 tons an acre up to 21, a 2-ton increase at 240 pounds of nitrogen. So I've given a lot of thought about how to analyze this. It's difficult to collect agronomic data. It takes replication. Replications take a year. I wanted to see can I squeeze some more out of this data, given that we do see some linearity in the response. So what I did is I compiled all of the data from all of the plots and all of the sites across all of the test years. And I plotted what I feel like are our only really relevant treatments: 120, 150, 180, 210, 240 pounds of nitrogen. And I fit it with a straight line. When we fit something like this with a straight line, the way we assess whether or not there's a difference is the slope different than zero? If the slope is positive, then that means as we're applying more nitrogen, we can have confidence that we're increasing yield. If it's negative, we would be depressing yield. In this case, what we're looking for is we're looking for the slope of this line to be greater than zero, and it's not. It is not greater than zero. So at this point, even after 3 years, 4 study sites, 4 replications per site, we still can't tease out a significant difference in yield. Not to say that it's not there, we just lack the replication. But one thing I think it clearly shows us is that the increase in going from, say, 180 pounds of nitrogen, which is our current maximum rate, to 240 is marginal at best. So for each topic area, I'm going to have take-home messages for you all. Here's my take-home message here. I think our current recommendations are solid. You know, granted, it's been 30 years since we've done a study with corn silage, but it appears to me that I don't see how you can go wrong by maxing out your nitrogen application rate at 180 pounds of nitrogen an acre. I think it's a good, solid upper recommendation. It has relatively low risk given that we're not seeing much of an increase in silage yields. As we increase our nitrogen application rate, it comes with something that's important, and that is low environmental impact. If we put that extra 60 pounds of nitrogen on, it has to go somewhere, okay? So I think currently that 180 pounds of nitrogen is a good estimate, upper recommendation. I don't anticipate that we're going to change that this year. That being said, based on the slope of the line, year in and year out, you're probably going to see somewhere around a 3/4 of a ton increase, you know, with a 30-pound nitrogen addition to that 180-pound upper estimate. So, Johnny, I don't know whether or not you think that's worth that extra nitrogen. Roy, I don't know. We're going to have to work on that some. There's a nuance that's coming on that recommendation. One thing's for sure. If you put the nitrogen on, it costs you money. There's no debate about that, right? So whether or not the return there is going to be there in any given year, you don't know, but definitely the cost is there. Now let's talk about silage quality. This is really an important finding. I did not discuss this last year because I only had 2 years of data. I didn't want to throw it up without having confidence that what we were seeing is correct, and so I wanted to show you that. I'm not going to show you each year's results. Your time's valuable. I want to go ahead and just summarize the same graph that I showed you, the last yield graph. This is, again, for every year, for 4 sites, for 4 replicates. We've averaged all those results, and we put them in according to our treatments, 120, 50, 80, 210, and 240 pounds of nitrogen an acre, and we plotted the crude protein content, and this is, at this point, this is rock solid. You know, we definitely see an increase in crude protein content as we increase our nitrogen application rates. This line is certainly greater than 0. The question is then, how much increase can we count on, right? You have to look for that line to tell us, okay, how much of an increase is it going to be? And right now, without more data to tighten up those error bars, it looks like about 0.2 to 0.5% increase in crude protein content for an additional 30 pounds of nitrogen. Again, you know, I don't know. We're going to have to look at that closely and see whether or not we can justify changing our nitrogen recommendations given that slight increase in yield that we think we see and this slight increase in crude protein content. This is going to be the crux of our analysis this year. We'll probably spend, as a committee, maybe a couple of months on this, Dr. Cross, trying to figure out whether or not, you know, we want to go ahead and change our recommendations based on the data that we have. So the other way that I'm looking at this is not just the concentration, but also the crude protein yield. Remember, we think we're probably having a slight increase in yield, right, with our nitrogen treatments, but we can't quite tease it out with the data that we have. So what I did is I took the crude protein concentration and I turned it into kind of a yield factor just to look at it and see whether or not, in fact, we are getting an increase in crude protein, so that we need something we can put a number on, that we can assign an economic value to. So when I do that and I plot it and we fit it best we can to figure out what the increase is on average, it looks like we're increasing, you know, the crude protein yield 30 to maybe 130 pounds of crude protein an acre for a 30-pound increase in the nitrogen application rate. Silage quality. When we measure it as milk yield, I didn't show any of this data in the interest of time. When we predict the yield, milk yield using the University of Wisconsin spreadsheet, we do not see any differences in milk yield. I mean, there's way too much variability. So that's not going to be the case, but I think I am confident at this point that we are influencing the crude protein content. And I think the crux of our analysis and making recommendations to you all is going to be whether or not we can justify that small increase in yield and that increase in crude protein content to change our nitrogen recommendations. And we'll be looking at that very closely for you all to make sure that we can justify it so that, you know, when you do spend the money to put the extra nitrogen on, it's warranted and you have a return on your investment. Okay, the second big thing that we're going to talk about is phosphorus removal rates and potassium removal rates. Those are very important because they're used in your nutrient management plans to set your manure application rates. We want to wring everything that we can out of that manure. We've got to get all the value out of it. If we're underestimating the phosphorus removal rate, and we all know manure is not a balanced fertilizer, right? If we're underestimating it, that's a problem. The fact is that the vast majority of our data indicates that our estimates of phosphorus removal and MMP are too low. I am very confident in saying that at this point. This is just a snapshot of a couple of years of the data. This is the results for the ETrack across all of our nitrogen application rates, and just shows the variability. And this is our value that we're using to estimate our, I'm not sure, this should be phosphorus and not potassium. I'm not sure. Did I skip ahead? Okay, anyway, if the correct graphs are up there, it's going to show you the same thing. Both of those estimates are too low. We are underestimating what that removal rate is. This is a really good way for you to understand. I know this is busy, but bear with me just a minute. This is each year of our study, 2017, 18, and 19. This is each of our experiment stations. And this is our best estimate of what our average phosphorus removal rate was for that station. Is it the same at each station? No. Is it the same at the same station over time? Remember that variability that we talked about? It's a little frustrating when we go to manage manure that the regulated community expects us to take one number and base our application rates on that one number. I have a hard time convincing them that there's a lot of variability in what we're doing. So the gist of it, though, is, and what's really important is this column right here. This column tells us, is this result the same as MMP's estimate of phosphorus removal? And in every case, at every site, it's not. It is definitely higher than what MMP is using currently. I think we should be using 4.3 pounds of P2O5 removed per ton of silage at 65% moisture. I want to back up. This is an extension publication that is in draft form that has already been reviewed by the Universities of Kentucky and Arkansas, and it's ready to go. And we're going to put the data in here, and then we're going to call Purdue and ask them, update our phosphorus removal rates. They're too low. So that's an important finding of the study. One other thing I want to mention, I know this is a busy graph, but you know, and you all are well aware of this, your phosphorus removal rates are high for corn silage. You're removing the whole plant. So be aware that, you know, you're going to be removing somewhere in the range of 100 to 150 pounds of P2O5 an acre. Our take-home messages, your removal rates are variable. You know, if you ask me to set a single number on phosphorus removal, I mean, I can try to do that. But the reality is it varies between farms, between fields, over time, perhaps with the nitrogen application rate. It makes it difficult to match what your actual crop phosphorus removal rates are, but I think we can do better than what we're doing right now. Our estimate right now is too low. Total removal is high. It does tend to increase a little with nitrogen application rates. Target your corn silage first and foremost to your manure to your corn silage fields. It needs it. You're going to be setting up a good system to recycle those nutrients. There is room to improve our production efficiency. This will be in the publication. I'm going to move on to potassium removal rates now. I'm going to move through this quickly because I know I'm taking too long. This is not the phosphorus rates. It is the potassium rates again. I'm not sure how I mixed that up, but we found the same thing more or less there. There's a lot more variability with the potassium removal rates, and that's not surprising. because potassium is one of those nutrients that plants can take up in what we call luxury format. If it's there and conditions are good, they'll take up more of that potassium than they actually need. So we see that contributing to an extreme amount of variability in the potassium removal rates. In fact, in 1 year the results here in East Tennessee were really interesting. Our estimate in MMP is 8.3 pounds of K2O per ton of silage. We were under that estimate significantly in 2017. We were over the estimate at Little River in 2018, and it was equivalent in 2019. So that's the kind of variability that we're dealing with. But in general, it appears that our estimate of potassium removal, what you see in your tables and your nutrient management plan, it's low. It should be a little higher than what it is. The removal rates, of course, for potassium are very high, 200 to 300 pounds of K2O an acre. You have to put manure on your corn silage fields for this reason more than anything else. You can't get behind on potassium because it will make your corn silage production uneconomical. You can't go out and buy that much potassium every year to produce corn silage. It's not economical. So target manure to these fields. Be aware that some mineral concentrations in corn silage increase with the nitrogen application rate. I'm just going to show the results for sulfur. This is the concentration here of sulfur. It does clearly increase as our nitrogen application rate increases. I'm just showing 2018 PREG here, but we see that at almost every station. That turns into, when you multiply that times yield, it almost doubles the removal rate of some nutrients. Sulfur is not the only one. Copper and zinc were notable over the long term. Could this create deficiencies? You know, I think it's a reason not to over-fertilize corn silage with nitrogen. This is one of the drawbacks, in addition to wasting your money, is to create yourself a hole in the long term, perhaps for some nutrients, and creating deficiencies. Prioritize manure to corn silage. I can't say that enough, because that manure contains all of these micronutrients and macronutrients. You can replace all of them by targeting manure to your corn silage fields. Where am I on time, Liz? Have I still got time? Okay. All right. Now okay. Is there any questions about small plot work? Good, bad, surprising? What's surprising you? Yeah. Okay. He might be using a little too much nitrogen. Listen, that's the service that we're providing you. I am trying. Pardon? Yeah. I mean, we need to be efficient as dairy producers. You have to justify every expense. And you shouldn't be applying more nitrogen than you can justify. I mean, that's just the reality of it. The data that you see there, I mean, it's the best that we can do for you all as a service to show you what the effects are. I mean, the effects for nitrogen additions are marginal. It's hard to justify. All right, so I'm going to move on to the large plot work that we did. Dr. Simpson is here. I don't see Tate Walker. Is Tate here? Tate is not here. I really appreciate Tate. You know, he has helped me so much in doing these large scale, kind of field scale applications. Here we're going to talk about work where we are using manure to fertilize the corn silage. It's really difficult to set up plots and use manure on those plots. It's a lot of hard work. And Tate had to take a lot of his time to help me. So Dr. Simpson, I appreciate that, and I acknowledge the assistance that he gave us. I want to talk about what we did in 2019. The results are very interesting. At planting, we put down on our plots 2 different types of fertilizer at planting. One was urea nitrogen, which mimics what we did with the small plot work. And we also put down 60 pounds of nitrogen with solid manure. Our solid manure nitrogen content's low, so the application rate's pretty high. But we targeted 60 pounds of nitrogen with 15 tons an acre of solid manure. And really what we wanted to know is when we paired this with our liquid manure applications using our center pivot, could we produce our corn silage crop using nothing but manure? That was one objective. Could we do that? And if we can mimic the yield, is the silage quality equivalent between something where we use some commercial fertilizer and a treatment where we use nothing but manure? On the liquid manure, we had 4 different application rates, roughly 4/10 of an inch, 1.5 inches total, about 80 pounds of nitrogen. So we're putting on a total of about 150 pounds of nitrogen. Now, I'm not using 210 on our study in our farm because I don't think I can justify 210 or 240, right? This is our treatment. This is really busy, but I want you all to understand the scale that this work was conducted at. These are 200-foot plots. They're 12 rows wide. We harvest the center 6 rows. That's a very large treatment for a plot size. We lined them up and used solid manure on one of the blocks, and we paired that with commercial fertilizer. So we compared them side by side, basically. And this is key. We looked at different seeding rates: 26,100, 27,700, 32, and 32,000 seeds an acre. And it's my effort to help you all make sure that when you produce this crop, you're doing it economically. We shouldn't be purchasing more seed than we can justify when we plant corn silage. So we wanted to look, in addition to comparing the solid manure and the commercial fertilizer, we wanted to look at the seeding rates. All this whole area here, which is more than 1,000 feet long by the time you count the alleys, this whole area is under the pivot. So when we swing the pivot around, we can put liquid manure on it. So all of it received the same liquid manure except for this corner down here. I'd throw one of these out for that, but we had enough replication to get past that. Yield. There's no letters up here because there was no difference in yield between our seeding rates, and there was no difference in yield between our urea and liquid manure and our solid manure and liquid manure. We were able to produce this crop using only manure and get the same yield as when we helped it along with commercial nitrogen fertilizer. There's a difference in cost, obviously, when we go from 32,000 seeds an acre down to 27,700. I had a producer call me day before yesterday and ask me about planting at 36,000. I don't think we can justify 36,000. But that's just not justifiable based on that. This is just 1 year's worth of work, but I don't think it can be justified. Many of you are going to question whether or not we had an effect on silage quality. We did look at the crude protein content of all of our different treatments. So this is all of the results compiled. 4 replicates at the different seeding rates with urea and manure only, and there's no difference in them. That tells me that the nitrogen that we put down in the manure was available to the crop. It took it up and used it, incorporated that into the crude protein in the plant. We also looked at the ear leaf nitrogen content. Remember that late season test that we talked about? We pulled that sample, we measured the nitrogen content in it, and in both cases where we used only manure and the commercial fertilizer manure, we had sufficient nitrogen present to produce the crop. So we met, I think, our objective. A couple things out of this first year: be judicious with your seeding rates. There's no need to, based on the results that we're getting, we shouldn't be putting 36,000 seeds an acre out. It should be lower than that to control your cost. You can produce quality silage with good yield using only manure. And then I'm going to leave off on this note. Give credit to that manure nitrogen. We have to be more efficient and to control our cost. And that nitrogen that's present in that manure that you're applying, you need to be giving it the value that it deserves. Don't dismiss that nitrogen and just replace it with commercial fertilizer you go out and purchase. It's not a wise thing to do. We showed that this year by producing this crop using only manure. That is it. As usual, if there's any input in the study design, I certainly want to hear from you all on that. Every year I go back to the state with this project, I add something else to the project. Appreciate your attention and appreciate being able to do the study for you. I hope that you see the value in it.